Hello dear colleague, my name is SYLVAIN MUKENA. Today I'm going to talk to you about disinfection in this environmental microbiology class taught by Professor N. Wang here at UAMS. Disinfection is the process of cleaning facilitated by a disinfectant. Disinfection is essential for the control of infectious disease transmission, preservation of foodstuff and biodegradable material. Disinfection is mainly accomplished by heat, chemical filtration, or radiation. A disinfectant is a physical or a chemical agent used to destroy pathogens able to cause infection or disease without killing necessary all microorganisms. Disinfectants are expected to kill more than 99.99% of the test organisms. Disinfections are usually applied in the water or inanimate objects such as fomites to control the spread of microorganisms. There exist several methods used to do the disinfection, such as thermal destruction, kinetic of disinfection, gamma and high energy irradiation, ultraviolet disinfection, photodynamic inactivation and photocatalyst, halogen, metal ion, and other chemical disinfectants. Numerous physical and chemical factors determine the effectiveness and rate of kill of a given microorganism and influence disinfectant procedures such as temperature, pH, relative humidity, and water hardness. Temperature has a major effect as it controls the rate of chemical reaction. pH affects the ionization of disinfectant and viability of the organism. Thermal destruction is heat destruction of microorganisms used in food industry because of the importance of process in killing bacterial and preventive foodborne spoilage. Factors that influence thermal destruction include water, fat, salt, sugar, pH, and other substances. Thermal death time is a time necessary to kill a given number of pathogens. The procedure to determine thermal death time is to place a known number of organisms in a sufficient number of sealed containers to get the desired number of survival of the test period. The reduction time is the time required to destroy 90% of the organism. There are more data in the book. Kinetic of disinfection. Inactivation of microorganisms is a gradual process that involves a series of physical, chemical, and biochemical steps. Today, the principal disinfection theory is the Cheat-Watson model, which expresses the rate of inactivation of microorganisms by a first-order chemical reaction, Nt over N0, where N0 is the number of microorganisms at time 0, Nt number of microorganisms at time t, K is the constant decay, where 1 over time and T is time. In water application, disinfectant concentration can be expressed as C multiplied by T, where C is the disinfectant concentration and T is the time required to inactivate at a certain percentage of pathogen under specific conditions like pH and temperature. Typically, the level of 99% inactivation is used when comparing C multiplied by T value to lower the CT value, more effective disinfectant. The method of CT allows the comparison of the effectiveness of various disinfection on different microbial agents. Halogen, chlorine, chloramine, chlorine dioxide, bromine, and iodine. Chlorine and its compounds are the most widely used disinfectant for the treatment of drinking and wastewater. Chlorine is a strong oxidizing product. Inorganic chloramine are produced by a combination of chlorine and ammonia for drinking water disinfection. Chloramine is used by some utility in the US to disinfect water. The disinfectant of chloramine is better than ozone. Bromine reactions in water are not similar to those of chlorine. Bromine effectiveness against bacteria such as Legionella virus and protozoa. Iodine is used as disinfectant for small-scale water treatment need. Ozone is a powerful oxidizing agent produced by passing an electric discharge through a stream of air or oxygen. Ozone is more expensive compared to chlorination when applying to drinking water, but has increased popularity because it does not cause cancer. Ozone treatment usually is followed by chlorination or chloramine to prevent the regrowth of bacteria. Ozone is more effective and powerful oxidant than chlorine. Metal ions like copper, silver, zinc, lead, cadmium, nickel, and cobalt can have or exhibit antimicrobial activity. Other chemical disinfectants like quote, which are quaternum ammonium compound, they are surfactants having both hydrophobic and hydrophilic property, like benzocalcium chloride and cetylpyridium chloride. They can also react like disinfectant. Ultraviolet disinfection is also called UV disinfection. This disinfection do not cause cancer or dust or other problem. The UV dose is expressed in microwatt per second per square centimeter. The factors that affect UV dose are water clumping, shadowing, suspended solid, turbidity, and UV absorption. There are three types of UV light source: low pressure lamp, medium pressure lamp, and pulsed UV light. Gamma and high energy radiation. Nucleic acid remain the main target of ionizing radiation. Factors that can influence the effectiveness of ionizing radiation include type of organism, composition of suspending medium, presence of oxygen, and moisture. The unit of rad is equivalent to the absorption of 100 air per gram mid-air. We always deal with microorganisms everywhere, indoor and outdoor, like bacteria, fungi, protozoa, virus. Some of them are beneficial like VBNC bacteria, and others can cause infection, even going to disease. It is better to prevent than to cure. Disinfection will help to reduce at safe level the number of pathogens in the environment, as health policy said, and to control the occurrence of disease at the community level and at personal level. Actually, the world faced to COVID-19, you must use one of the disinfection techniques like hand sanitizer to maintain safety against COVID-19, and also disinfect for mites to avoid the infection. Thank you for the attention you gave to my presentation, and the best wish to you all.